Throughout Chapter 7, we've looked at systems of linear equations, and now in the final section of the chapter, we're going to look at systems of linear inequalities. So we have just a couple of steps to take here to find the solution of a system of linear equalities. First of all, graph each inequality. Remember that this is going to be a line in two dimensions. We're working with x and y, and then we're going to shade a half plane on one side or the other of that line. And then we're going to find the intersection of the half planes for the two graphs. And that intersection is going to show us the solutions. So let's go ahead and look at some examples here. Notice the directions say, sketch the solution to each system of inequalities. So if we look at our first graph, we have y less than negative 1/2 x plus 2. So we have a y-intercept of 2, and we have a slope of negative 1/2. So we can go either up 1 and to the left 2, or down 1 and to the right 2. And then we notice that this y cannot be equal to negative 1/2 x plus 2, and so we're going to draw a dashed line. So something like that. Remember, this is always helpful if you have a straight edge or a ruler, so you can make a better line here. And then we notice that this is in slope-intercept form, and remember in slope-intercept form that less than will tell us to shade to the below the line. And I'm going to go ahead and use green here, and I'm going to shade basically perpendicular to that line. So everything that's below this line is going to be a solution of the first inequality. So for example, if you tested the origin 0, 0, substitute 0 for y, 0 for x, negative 1/2 times 0 plus 2 is 2, 0 is less than 2, and that's why the origin is shaded. Okay, now look at the second line. We have y greater than or equal to 2x minus 3. So there's a y-intercept of negative 3 and a slope of 2, so I go up 2 and to the right 1, and it can be equal to 2x minus 3, and so we have a solid line. So we draw a solid line here, and then because it's in slope-intercept form already, we can go ahead and shade above that line. And so I'm going to shade here above the line. And the part that gets shaded twice is our solution. Okay? And if you were to see this in a multiple choice question, what you would see would be something like this. We have a solid line here, and it intersects with a dashed line, so something like that. And then what's above the solid line but below the dashed line is our solution, and so you would see something like this. So just this area is shaded. That's the area that works for both inequalities. Okay, let's look at number 2. Y greater than 3x minus 1 and y greater than or equal to 3x plus 2. So for our first line, we have a y-intercept of negative 1, a slope of 3. So 1, 2, 3, and over 1. And this is going to be a dashed line because it cannot be equal to. And so it looks, whoops, something like this, roughly speaking, very roughly. And then for our second line, oh, and we want to shade also. So go ahead and shade above that. You can just draw both lines and then deal with your shading, but I'll shade first. So everything above that line works for the first inequality. And then for the second inequality, we have a y-intercept of 2 and a slope of 3. So 1, 2, 3, and up 1. And this is a solid line because it can be equal to. And notice that we have the same slope. So we have two parallel lines, and then here we shade again above that line because it's greater than or equal to 3x minus 2. And so once again, everything that got shaded twice is a solution for both inequalities. And notice the only part that got shaded first that isn't a solution for the second inequality as well is the space that's in between the two parallel lines. So again, if you were to see this as a multiple choice question, you would see a dashed line and then a solid line that's parallel to that, and then nothing in between gets shaded because that only works for the first inequality, not for the second. But everything that's above that solid line, that second line, is a solution for both of those. In number 3, we have y greater than or equal to 2x plus 3 gives us a y-intercept of 3 and a slope of 2, so up 2 and to the right 1, or you could also go down 2 and to the left 1. And this can be equal to, so it's a solid line. So something like that. And we're above that line because it's greater than or equal to. And then for the second line we have a y-intercept of 2 and again a slope of 2. So up 2 and to the right 1 or down 2 and to the left 1. So we have a solid line here, parallel to the first one. But now in this case, we're looking at what's below the line because it's less than or equal to. Now notice nothing got shaded twice, and so there's really actually no solution here. And if you were to see this in a multiple choice problem, you would see a solid line here, a solid line here that's parallel, and there's nothing shaded there because there's no solution for both of these simultaneously. Okay, last example. Notice we have standard form here rather than slope-intercept form. So if you want, you could, for example, plot the x and y intercepts and then use a test point to figure out whether you should be above or below the line, or you could go ahead and rearrange these in slope-intercept form. So let's do that. So I'm going to subtract 2x from each side, and then we get, don't forget your negative, negative 3y greater than or equal to negative 2x plus 9, and then divide by negative 3, which gives us y. And then because we divided each side by a negative, we need to reverse that symbol and make it less than or equal to. Negative 2 over negative 3 is a positive 2/3 x, and then 9 divided by 3 is a negative 3. So we have a y-intercept of negative 3, a slope of negative 2/3 tells us go up 2 and then to the left 3, and it can be equal to 2/3 x minus, oops, sorry, we have a positive slope. Take that back, up 2 and to the right 3. Hopefully you caught that. Okay, so a positive slope of 2/3, and it can be equal to, so it's a solid line. And then we're going to be shading below that line. So everything below that line is a solution. So if you were to substitute 0, 0 in here, so you would have 0 is substituted for x, 2/3 times 0 is 0, minus 3 is negative 3, but 0 is not less than or equal to negative 3, hence the origin should not be shaded. And it isn't, so we went the right direction. Now let's look at the second inequality. We have 2x plus 3y is less than or equal to 3, so subtract 2x, and we get 3y less than or equal to negative 2x plus 3, and then divide by 3. And we get y less than or equal to, we divided by a positive, so we keep the symbol the way it is, and then we have negative 2/3 x plus 1. So we have a y-intercept of 1 and a slope of negative 2/3, so this one is negative 2/3, so 2 up and then 3 to the left. Or we could go down 2 and 3 to the right. And then it can be equal to, so we go ahead and draw a solid line through our points. And it's less than or equal to, and so we shade. So everything that gets shaded twice is a solution. So this area in here where you see the crosshatch is our solution area. So if you're doing this on paper,
One thing that works nice is if you have colored pencils or highlighters, you can go ahead and use colors to help show where the overlap is, or if you're just using a pencil, you can draw your shading in different directions so it's clear to see that here this area has been shaded once, this area has been shaded once, this area hasn't been shaded at all. This area is where we have our solution because it's been shaded twice. And again, if you were to see this in a multiple choice question, you would see one solid line, a second solid line that intersects it, and this region in here would be shaded. So all of the points in this area and continuing on below would be a solution to both of these inequalities. So there you go with solving linear systems of inequalities. Enjoy and look forward to a test coming up soon.